close your eyes for a second. Who is the you that just noticed the darkness? The you that is hearing this voice right now? Our brains are essentially just chemistry and electricity, yet there is an undeniable feeling that someone is home. The philosopher David Chalmers calls this the hard problem of consciousness. A self-driving car and a human driver are both arrangements of particles obeying the exact same physical laws. But while the car processes millions of data points to stay on its path, it lacks the subjective experience of the road. This gap in our understanding has real-world consequences. We currently lack a mathematical way to prove if a coma patient is completely blank or trapped inside their body, fully aware. We face the same wall with artificial intelligence. We can measure its output, but we cannot objectively verify its sentience. To solve this, physicists treat consciousness as an emergent property. Just as wetness doesn't exist in a single water molecule, but appears when enough of them lock together in a specific pattern, awareness may be the byproduct of how matter is arranged. If we can identify these special physical properties, we can begin to calculate exactly when and where matter begins to wake up. Some researchers look for this pattern at the smallest possible scale. The physicist Roger Penrose and anesthesiologist Stuart Hameroff proposed that consciousness is generated at the quantum level. They hypothesize that tiny protein tubes inside our neurons, called microtubules, act as quantum computers. In this model, these tubes enter coherent quantum states, and the momentary collapse of those states creates a pulse of subjective experience. However, calculations show the human brain is too warm and wet for this to work. A delicate quantum state in those conditions would collapse in a femtosecond, which is too fast for a biological thought to form. This chart displays how neuroscientists look further up the ladder at the biological network of neurons. Brain scans show consciousness operating in a specific mathematical range. It is neither a dull flatline nor random static. It is a structured, layered waveform. But high biological activity isn't a perfect indicator of awareness. During an epileptic seizure, different parts of the brain become highly synchronized. The neurons fire together in massive waves, yet the patient remains completely unconscious. This suggests that consciousness requires more than just activity or synchronization. It depends on the specific structural way that information within that network is integrated. This is the core of integrated information theory, or IIT. Developed by neuroscientist Giulio Tononi, this framework assigns a mathematical value called phi to any system. Phi measures consciousness based entirely on how a system distributes and combines information. A camera captures millions of isolated pixels. Because this data doesn't interact, its phi value is near zero. The brain works differently. Neurons achieve a massive phi score by feeding information back into one another, combining data into a unified whole. Testing this theory in the real world is computationally expensive. Calculating the exact phi value for a microscopic worm with only 300 synapses would require our best computers to run for several billion years. There are also logical hurdles. Computer scientists have demonstrated that it is possible to build simple, unconscious mathematical grids that produce massive phi numbers, suggesting that integration alone might not be the full story. While IIT provides a way to quantify integration, we are still refining the formulas to determine if mathematics can identify exactly where subjective experience begins. We can apply these same metrics of integration and complexity to modern artificial intelligence to see if these systems are truly waking up. Despite their ability to write poetry, large language models operate on feed-forward architectures, processing data in a linear stream. They lack the dense, recursive feedback loops found in the human brain. This structural gap is why many researchers consider these systems philosophical zombies. They can simulate intelligence without any inner awareness. To explain the gap between hardware and feeling, microprocessor inventor Federico Faggin suggests a different perspective. He proposes that consciousness is a fundamental field in the universe, similar to a Wi-Fi signal. In this model, the brain and body act as a biological drone. They are the hardware that tunes into and receives the conscious field, translating its signal into physical action. This would mean the subjective feeling of warmth, or the color red, doesn't exist inside the neurons themselves. The neurons merely process the data, while the experience happens within the field itself. Mathematics allows us to move past the mystery of the soul and look at the structure of our thoughts.